Now we are at the last example problem for symmetry. So if you look at this situation here of this element of this member, it's also 2D planar with two holes in it of radius r. There's a load constant which is supposed to be a concentrated load, so it should not be Newton per millimeter but just P Newton, which is acting at the exactly at the center of this right edge, which is divided by b by 2. You have a certain length and there is a fixed boundary condition on the left side here. The observation here important is that they are all 2D planar, so therefore again the thickness is a number that you add into the program. Now if I start doing the same thing as I've done before, I would really hope that you can do this before I start solving it, so actually pause the video and think about it and start doing the symmetry conditions here. So if you look at this, we have now this structure. The geometry is symmetric about both x and y. So if I have the x here and I have the y here, then they are symmetric about both conditions. The load is also symmetric in both conditions because it lies at the same angle. Well, actually it's not symmetric because there is no load acting over here, but that can be replaced. And the boundary condition is also not symmetric about the y-axis, but it is symmetric about the x-axis because you have the same boundary conditions on two sides of the axis, but not here and here. That doesn't exist. So it's very simple then. We know that it is only symmetric about the x-axis, so we can only draw the top half. So you have a edge condition here. You have the edge and the two holes that will show up right here. So that's the half of the geometry and the half of the boundary condition. Of course, there has to be an updated boundary condition now, and we are quite aware that if you have the symmetry plane in X, then basically you don't want it to move perpendicular to it, and you can allow it to roll in the same direction. So these are all roller supports. Then there is a load which is applied, and since it's a concentrated load and the geometry is halved, it's also halved. So that's the reduced model for the final example for symmetry concerning two-dimensional objects.